Okay, so assuming that we know the concepts of AC and DC loading, we will just solve a simple problem to find out the Q point for a transistor, and we'll simulate the same problem using multisim software, which I told, and you will be finding that the answers what we get are going to be exactly same. And multi-sim software can simulate only DC load line, and AC load line we are going to manually work out. Okay, so DC load line values we can cross check using multi-sim software. AC load line, we are not doing any AC analysis now, right? So we cannot do that using multi-sim software. Okay, so see the problem what you see on the screen. In the transistor shown in figure 1.2a, see, this is the diagram what we are going to consider. See this diagram, it's a common emitter amplifier. You have VCC, RB, RC, RL. So I have three resistors connected and I have VCC. Okay, so for this circuit, we are going to find out the operating point for this circuit. So this circuit, you keep it in the mind and see the values are given. For the circuit shown in 12.1.2, RC is 8 kilo ohm, RL is 24 kilo ohm, and VCC is 24 volt. Okay, so these are the values for the resistances given, RC, RL, and VCC. RB is not given because you know RB is a base side resistor. So RB value generally it will be very, very high. You can take the value of RB as very high because the base current has to be very, very small. So for this problem, we are going to see draw the DC load line, determine the Q point, and also draw the AC load line. So is the problem clear to you? So in exam also the same type of problems may come. You will be asked to design the Q point for a particular operating condition. See if the resistance values are going to change, the Q point will also change. Okay, for this resistance values, we are going to find out the Q point. As I said before, the resistant values, the voltage source VCC value will determine the Q point of your transistor. Okay, so first we will be doing DC load line. So I told you this is the only equation you have to remember for DC load line. VCC equal to VCE plus IC into RC. This equation is very, very important for any biasing circuit. And to find the endpoints, what you will do, first I will put IC equal to 0. IC equal to 0 means this is the x-axis point. Okay, so if you put IC equal to 0 in this equation, you will get VCC equal to VCE. But you know the value of VCC given in the question is 24 volt, so I can get VCE equal to 24 volt. Okay, the first point of the DC load line we got, the first end point. Second endpoint, you have to make VCE equal to 0. We are going to find what is the intersecting value on the y-axis. You have to put VCE equal to 0. If you put VCE equal to 0, you get VCC equal to IC into RC. So from that, I can find what is IC. Okay, I can find IC equal to VCC by RC. VCC is 24, RC is 8 kilo ohm. So if you divide, you get 3 milliamperes. So I got the other endpoint of the line. So I will draw the graph. So x-axis is going to be VCE, y-axis is going to be ISO. You will get a line like this. So this is going to be 24 volt, and this is going to be 3 milliamperes. This is your DC load line. Okay, you're able to understand the DC load line. You can name the points. This point 24 volt is point B, and 3 milliamp is going to be point A. So AB represents the DC load line for the transistor. Any doubts in the DC load line part design of the